Hello everyone, this is Yongkai of Group 3. Now we will introduce our team project, make tails better and make workers more efficient. We divided our content into 5 parts by applying the DMAIC methodology. At the beginning, I want to ask a question. When you walk or ride on our campus, have you ever noticed the tiles under your feet? I guess most of you will answer no. The second question is that have you ever noticed the broken glass in our campus, such as W3, W4? Yeah, I guess it may look very ugly or uncomfortable. Yeah, to be honest, our campus is very splendid and our dormitory is very comfortable. To some extent, this depends on the good tile in our campus. Look at this photo. This is the display workshop in the tile production plant. The defect samples that the tile quality inspectors must memorize before officially taking up their posts. At the end of tile production line, quality inspectors need to visually identify more than 10 types of grade defects in different types of tiles and grade and sort them to ensure the product quality of the tiles. This is not just an exam. Every day, the workers need to identify, grade, sort, identify, grade, and sort. This is very terrible and exhausting here. Let me give an example. In Mona Lisa tiles, they have 10 producting lines. Every procedure of the line need 4 workers, and this means that they need over 100 workers in their company just to finish this project. For workers, they observe the surface of tiles under high light for a long time to find defects. This leads to unstable manual accuracy, low processing efficiency, and untimely feedback. Most importantly, their eyesight is not very so bad. For the factory owner, the quality of quality inspection is uneven and the cost is high. Production capability and quality are greatly affected. This directly influence the money. Yeah. For the consumer, they face a series of problems such as short service life, easy damage, high maintenance costs, and reduced aesthetics, which affect the comfort and the safety of the overall living environment. It is extremely necessary to make the quality inspection process intelligent.
Okay, so we define our problem as the tile production defect detection. And here are some common defects of the tile production, which is the broken edge, the broken corner, and the point blemish, and the crack and the stretch. And the data sets we use is come from a well-known tile enterprise in Foshan, and the professional shorting equipment is set up on the production line to collect the real data of the production process on the spot, covering all the common defects of the tile. And this dataset is have about 20,000 samples in there, and each samples we take 3 pictures. And to evaluate our algorithm, we design the score, and which is combine the accuracy and the MAP. And the accuracy, which is stand for the classification indicator, to determine whether there are defects or there are no defects of the samples. And the MAP, which is stand for the mean average precision, and which is to evaluate the accuracy and the recall of the algorithm, and combine and we add them together with weights and to calculate the evaluation score of the algorithm.
Let me introduce our algorithm. We found that in the dataset, the size of objects is non-uniform, with a higher proportion of small targets, and the ratio of length to width varies greatly. In addition, imbalanced sample sizes between different categories are very serious, which can lead to overfitting of the model in certain categories and underfitting in certain categories. To address the issue of imbalanced categories, we use the resampling method. First, we calculate FC. This is the frequency of occurrence for each category. Then we calculate RC, which means the resampling coefficients for each category. Finally, we calculate RL, the resampling frequency for each image in the training set. The figure shows the proportion of each category before resampling, and the right figure shows the proportion of each category after resampling. We use multiple data augmentation strategies to help improve sample diversity. A strategy is copy-paste, which is proposed by Google for data augmentation in segmentation tasks. In tail inspection, due to the extremely small proportion of defects in the original image, it can cause a significant imbalance between positive and negative samples. Therefore, copy-paste can help alleviate this problem. Due to its need for pixel-level annotation, it's not directly applicable to detection tasks. However, in tail defect detection, the content of the images is relatively single, so we propose the copy-paste method suitable for the detection task. Although there is no pixel-level annotation, we can directly paste the patch of the entire target area onto another image, and at the same time, ensure that the original image is cut in the same area as the template image to prevent the model from simply learning texture boundaries. We randomly expanded the cropped area outward to ensure that the network is learning the flaws themselves. In addition, our strategies include random rotation and flipping, color transformation, and random cropping. We notice that the data has rotational invariance, so we use the random vertical and horizontal flips, as well as rotation. The categories of edge defects, corner defects, etc. only rely on geometric shapes, so we adopt the color transformation method, including brightness and contrast. We randomly crop some regions of the entire image, then expand the resolution to be equal to the original resolution and use it for training. We use ResNet 50 as baseline and propose a deep and shallow fusion network. This network contains the features extracted by traditional algorithms into channels in the deep and shallow layers of the model. ResNet is an improved based on ResNet. Introduces the split attention module. Split attention combines the output element-wise of each group in the upper layer, groups the feature maps by channel, and applies R softmax to the group convolution to achieve a cross-channel attention mechanism. Due to the ability of the split attention module to implement cross-channel attention mechanisms, this model is perfectly suited for our traditional features and deep model features that are contained by channel. We conducted experiments on stitching only in the deep or shallow layers of the model and found that the best stitching effect was achieved when stitching was performed simultaneously, which score is nearly 74. We extract feature points from the defect map and template map using the solve operator, Align the template with the defect map through perspective transformation, and finally, differentiate to obtain traditional features. Due to the complex patterns of ceramic tiles, it's difficult to distinguish them from defects. After aligning the difference in this way, most noise can be suppressed while highlighting the features of defects. The flow chart is as follows. That's all. Thank you.